In the previous segment of this demo, we saw how to import a Jupyter notebook into SageMaker. So the instance that we had previously provisioned is now ready to use. So if you go ahead and click on this link to open the Jupyter notebook, it should take you to this page, and you can go ahead and click the link to open the GAN notebook. This takes you into the main GAN notebook that we're going to be diving deep today on. As you see here, a Jupyter notebook is a great tool for machine learning engineers and scientists to develop and iterate on machine learning code. It provides a rich interface with code, visualizations, text, and mathematical equations all in one place. The goal of this specific notebook is for us to walk through a fun machine learning use case end to end, starting with data pre-processing, training, followed by evaluation and inference. Along the way, as we step through all the different cells in the notebook, we also want to look at good software engineering and machine learning software development practices, along with also understanding the key algorithm that powers this notebook, which is GANs. Before stepping further into the various cells of the notebook, let's look at GANs at a high level. We use GANs for generating AI-inspired music in this notebook. Given a single track piano input, we want a model that can create a multi-track piano output that is inspired by Bach. Bach is a classical musician and composer, and the reason we say it's going to be inspired by Bach is because the dataset we trained on is a Bach dataset. So GANs at a high level consists of two networks that are constantly competing with each other. A generator network that tries to generate data based on the dataset distribution that it was trained on. For example, in this use case, we want a generator that's trained on Bach dataset to generate music that's Bach-like. And a critique which has been trained to differentiate between the real data versus the data that is being generated by the generator. Now, by alternatively training the generator and discriminator, or the critique, which constantly gives feedback to the generator learns to produce more and more realistic data with time until the loss functions converge. Now let's jump into the code right away. The first component of this notebook is meant to manage various dependencies and configurations. First, we install the different packages and dependencies that are required to run this notebook. Once we install the various packages, we then want to import these packages into the code. And after that, we want to define the various configuration variables as well as paths for fetching and storing data. Remember that it's never a good idea to hardcode configuration parameters as it is error prone. An even better practice is to move configuration variables into a separate config file so that it gives you a clean separation between the code and configuration variables. For the sake of easy reading, we have put all of them together here. Uh, Also notice that it's always a good practice to comment well on your code because this allows for easy collaboration between various members of a team.